Hi, welcome to part D and E of this question. This is the last video on this question, and if you haven't seen previous parts, then I'll leave the links down below so you can check them out before you watch this one. In part D, we want to find the height of the arch at a horizontal distance 12 meters from A. Horizontal distance implies that x is equal to 12. And we want to find the height, which is the y value when x is equal to 12. So we know the formula already, and we're going to sub in x is equal to 12 and find the corresponding y value. Since we're taking x is equal to 12 in this case, so every time when we see x, we're going to replace it with 12. So this is not too difficult, considering the fact that you can use a calculator in this section. With your calculator, we can find the y value is approximately equal to 3.28 meters. So y is approximately equal to 3.28 meters. So this means when the horizontal distance from A is 12 meters, the height of the arch is equal to 3.28 meters. So in part E, we want to tow this 20-meter wide floating platform and making sure that it can be towed under the bridge. So before we start, we discovered that we need to convert the unit first, since the clearance was given in centimeters in this question, but we've been using meters all this time. So now everything is in meters, and we want to find the greatest height, which is the maximum y value. So the line of symmetry is right in the middle, and I'm going to draw the plane first. So the line of symmetry is right in the middle, which passes through turning point B. This divides the graph into two parts, and we know the two parts are the same since they are symmetrical. Let's focus on the left part of this graph. The distance from the origin to the center of the platform is half of 50, which is 25 meters. So let me label this. So this distance is 25 meters. The length of the platform is half of 20, which is 10. So that means this length is 10 meters. In addition, we need to leave 0.3 meters clearance on one side, so we also need to take into account 0.3 meters here. In other words, we need to leave enough space for the floating platform, otherwise it'll get stuck. So taking into account the length of the platform, the width of the bridge, and the clearance, what's the maximum x value we can take that will enable us to tow the platform? So here we're asking, what's the maximum x value? So the maximum x value is equal to 25 take away 0.3 take away 10, which is 14.7 meters. So now that we know the maximum value x can take is 14.7, now sub x is equal to 14.7 into the original equation, and it'll give us the y value we're looking for. And this y value is the greatest height of the deck above the water level when x is at its maximum. So now in this equation, every time we see x, we're going to replace it with 14.7. And also solve this equation using our calculator, we found that y is equal to 3.736 meters. So this is the last video on this question, and I hope you find it helpful, and see you in the next video. Bye!